Welcome. This is Mr. Vandermaiden again, and I'm glad you've stuck with us. We're starting part 3 with the definition, postulate, also known as an axiom. It's simply a statement accepted as fact, without proof. Now let's learn a few postulates. Our first postulate I like to call 2 points, 1 line postulate. Simply says that through any 2 points, there is exactly 1 line. If you think about it, this has to be the case because in order for more than 1 line to go through 2 points, one of the lines would have to be curved. And we already know that lines are straight paths. Hence, this is a postulate that we can simply accept to be true. This is also why we use 2 points on a line to name it. With that, let's look at another definition, intersection. That is the set of all points 2 figures have in common. You'll notice in our figure here that we have 2 lines and our intersection there is point B. Notice how there's no dot at point B. Whenever we have 2 figures intersecting at this point in time, we're going to use these postulates and definitions to intuit what the intersection should look like. Speaking of postulates, let's move on to our next one. I like to call this one 2 lines, 1 point postulate. As you saw in our last figure, if 2 separate lines intersect, then their intersection is exactly 1 point. So notice again here at point B where lines L and M intersect, there isn't a dot. We know from this postulate that since the 2 lines intersect, point B is exactly that, a point. And our next postulate I like to call 2 planes, 1 line. It says, very much like our last postulate, that if 2 separate planes intersect, that their intersection is exactly 1 line. 2 lines create 1 point. 2 planes create 1 line. Let's see what we can do here. Notice the prism here in our figure. Each surface contains part of a plane, so let's imagine each surface of this prism extending on forever. What is the intersection of plane ABC and plane DHG? I want to impress upon you how important it is to get used to the idea of simplifying the figure. So let's remove everything except plane ABC and plane HDG. Notice where they intersect? Now imagine that segment continuing on forever, and we have the line DC. Okay, you try this on your own. Press pause when you have your answers, press play, and we'll continue on. Excellent! You've got your answers. Let's see how well things went. If you look at the line FB, you will notice that there are 2 planes that basically intersect to create it. That would be plane FBA and plane FBC. Please remember that you could use any names from the 4 points in each of those planes. Now, why do you only need to find 2 common points in order to name the intersection of 2 planes? To answer this, you just need to remember 2 postulates. The 2 planes, 1 line postulate, which says that the intersection of 2 planes is going to be a line, and the 2 points, 1 line postulate, which says that through any 2 points is 1 line. So therefore, you only need 2 points in common so that you can name the line. All right. Let's move on to our next postulate. I like to call this one 3 points, 1 plane. And that simply says that through any 3 non-collinear points, there is exactly 1 plane. This is like a tripod. Have you ever wondered why we always have tripods and not quadrupods or heptapods, which would be 7 legs? The reason is very simple. Anytime you have 3 points, it will create a plane and it will be stable. So like on a camera tripod, you have 3 points, and those 3 points determine a plane. This is also why we name a plane using only 3 points. So let's try it. What plane contains points E, G, and H? Shade the plane. Looking at our figure, we can see that points E, G, and H are down on the base of the figure. So we would shade in the bottom of the figure. So what plane contains the points A, B, and G? Shade the plane. Now this one's a little bit trickier, but notice A, B are in the upper left-hand side of our figure, and G is in the lower right-hand side. So we have to use that little trick that even though something is not there, we can draw it in. So we can draw in a parallelogram that includes A, B, G, and the 4th point H. Now we can shade in that plane that goes in diagonally through our prism. So try this on your own. Press pause, and when you have your answer, come back and see how well you've done. So you have your answer. Excellent. For problem number 1, did you shade in the plane that goes diagonally through our figure from the top back of the figure to the bottom front of the figure? If you did well. Now, what is the name of a line that is coplanar to line AD and line DC? Well, if you notice, line AD and line DC are both in the top of the figure, and so therefore any 2 points creating a line in the top of the figure would be fine. Don't forget that you can use the lines that go diagonally through the top of the figure as well. Excellent job. At the end of each lesson, we are going to pose to you a few questions that we want you to do on your own. If you have any questions concerning these problems, please make note of them in your notes. That's what the right-hand column of your notes is for, and ask them when you get to class. It's a good way to start the practice problems that you'll be receiving in class. Press pause. Copy these questions down, then advance to the next set of questions and copy them as well. Here's the next set of questions. We'll see you in class.